Welcome to another fabulous edition of Comet Algebra. This video is for Algebra 2, Chapter 6, Section 4, Modeling with Quadratic Functions, which is another way of saying word problems. I know you're all thrilled. We need to define a term here, residuals. You will likely see this term on tests like the SAT, the ACT, and so we'll talk about it and then we'll discuss it in the word problems. Residuals, I think of it as sort of the leftovers. It's a number that represents the difference between the actual known answer and like a value that we find with a regression line. Remember, regression lines give us estimates, and sometimes our estimates are right on, and sometimes there's a little difference between what we predict the value will be and then when the event happens we see what the actual value is. So the residual is that difference. On a project we're doing later this year, you will be asked to find the residuals. You'll make a prediction with your regression line, and then you'll see what the actual number is, and then you'll have to find the difference, or here it says the amount of error, how far off you are. So let's start these word problems. The first one, I believe I printed these out so that you don't have to write them down this time. So just read number one, building a dog kennel, and I'm going to draw a picture to go along with the problem. So if you read it, we have 28 feet of fencing and we need to maximize the area of the kennel. So this part that is the wall, we do not need any fencing for. So we got to make these three sides out of the 28 feet. So let's call the width here, if that's x, and if I drew this triangle, or I'm sorry, rectangle perfectly, they would both be equal. So we had 28 feet here, here, and here. We used up x of it here, we used up x of it here, so what's left for this part would be 28 minus 1x minus another x, and that's 2x. So now I have the sides labeled, and that's maybe one of the most tricky parts of these. So now determine what the maximum area is. If you remember that the formula for the area of a rectangle is base times height, we need to multiply our length times our width. So we can go ahead and multiply these. We would get 28x minus 2x squared. And if we want to find the maximum area of this is a maximum problem, we are looking for the vertex of this quadratic. I am choosing to use the minus b over 2a method because I think it's easy. So I have minus 28 over 2 times negative 2, which I simplify to 7. So now I have to plug in the 7 to the quadratic to find the y value of the vertex. Alright, so I put the 7 in here for x, and then if I do the math and multiply this out and subtract it, I end up with 98. So now I know my vertex is at 7, 98. So we need to interpret this. So the x right here is the width of the dog kennel, and I don't know the length yet, so I'd have to take the 7 and put it in here, and then 28 minus 14 is 14. So the dog kennel then would measure 7 feet by 14 feet. So I have found the length and width, and then the maximum area would be 98 feet squared. Example 2 asks us to find two numbers whose sum is 42, add up to 42, but these are the two numbers that have the greatest product, whatever that product is. So we got to find the two numbers and we have to find that product. So we know we're going to be multiplying after we find our two numbers. Well, if their sum is 42, that means if you add the two numbers together you get 42. I don't want to use an x and a y here because I need to write a quadratic. because this greatest, I'm realizing that that's a maximum, so this is a vertex problem, and I just want to have one letter in my equation of the quadratic. So if x is the first number and you add the 2 to get 42, then the other number would have to be 42 minus x. So that's my second number. So take a minute and see how to write that. And now to write our function, we are just going to, we're looking for the maximum product, so we're going to multiply these. So go ahead and multiply it out. And this is what we want to find the vertex of. Again, I'm kind of partial to the minus b over 2a method. So if I plug in the b and a and simplify this, I get 21. And now to find the y of the vertex, we want to find f of 21, or put the 21 in where the x is. So if I did my math right, I get 882 minus 441, which is 441. So now I know my vertex is 21, 441. So we need to interpret this. We're asked to find the two numbers. And when you're maximizing some picture, you know, I mean, 1 plus 41 adds up to 42, but they don't have the greatest product. So if you keep going, you will find that 21 is your first number, and then 21 is your second number, and these two together give us the maximum product, and this product is the 441. So in example 3, you have purchased a goat, and you are going to build a pen for this goat. You have 354 feet of fencing, and you want to have the maximum grazing for your beloved goat. Also, we're going to leave a 6-foot opening. So we're going to use the 354 feet of fencing, plus we have a 6-foot gate. So we're going to add this together. So the total perimeter will be 360 feet. So that's the number we're going to work with, and we're going to try to get the maximum area we can. Since this is an area problem, I know that I'm going to be taking base times height, or length times width, however you think of it. So those are the two things I want to label in this rectangle. I want this base, and I want this height. Well, I know that if I added up all four sides, they would add up to 360. But I want to label this and this. So if I call the height, if I call that x, if the whole thing is 360, then this side plus the bottom only adds to 180. Therefore, I could state this base as 180 minus x. So now writing my quadratic, the area of the rectangle is base times height. Go ahead and multiply this out, distribute the x. This is what I want to maximize, so I need to find the vertex. Again, I'm going to use minus b over 2a. So if b is 180 and a is negative 1, I get that the x value is 90. So now we want to plug in the 90, a of 90. So I have 180 times 90 minus 90 squared. If I did the math right, I got 8100. So there's our vertex. And now we need to interpret it. Well, this x is 90, so this side is 90. This side is 180 minus 90, which is also 90. So interestingly enough, to maximize the area for our precious goat to graze, we would build a square pen, and it would measure 90 feet by 90 feet. And what is that maximum area? Well, we maximized it at 8,100 square feet. All right, this is the problem where I picture you in your college dorm room when you started an online business and you're selling whatever product, and you want to get the maximum income as any business owner would. So you have some information here. You're selling right now 100 of your items per day, and you're selling them at $150 each. But you're wondering if you're getting the maximum income, because as you've noticed over the past few months, every time you drop your price a little bit, when you drop your price $5, you sell more products. Your sales go up by 5. So you're contemplating this, and you want to look at a parabola, a quadratic here, to see if you're selling it if you're at the maximum price, if this 150 is bringing in as much money as you could make. The key to this problem is choosing your x correctly. So I'm going to give this to you. Your x in this problem is the number of times that you are going to decrease the price by that $5. Okay. So this is the key. If you know what the x is, I may even have to remind you of this on the test. X is the number of times you're changing the price. So now we use this x to write a couple of equations, because there's another piece of information that you need to know going in. You need to know how income is calculated. You maybe know this already, but the income equals the number of sales times your price. This is what we're going to use to give us our quadratic. So we needed to know what the x is, and now we have to use this x to write a phrase here, an expression for the number of sales and an expression for the price. And we're adjusting both of these. The sales are being adjusted up, hopefully, and the price is being adjusted down. So that's what we're going to use our x for. So let's do both of these. Let's find an expression for the sales. Right now we're selling 100 items per day, so that's where we're starting at, and we are hoping that these are going to increase by 5 every time we adjust the price. So we're hoping these are going to go up by 5 items every time we adjust the price. So that's where the 5x comes in. The price, right now our price is $150, and we are going to be decreasing the price in the hopes that we're going to sell more. We don't think we're at that sweet spot yet. So we're going to subtract the price a few times by $5. Okay, now this is just kind of a coincidence. These are both 5s. It usually doesn't work out that way. It's because this is an increase of 5 products when we decrease the $5. So now let's set up our quadratic to find the income. So here's our equation for income, and yes, you have to FOIL it out because we want it in standard form. So if I FOILed this correctly, and I really do wish you would check, I got 15,000 plus 250x minus 25x squared. So again, doing the minus b over 2a, I end up with that the x value of the vertex is 5. Now we need to find the y value of the vertex, so we're going to plug in the 5 to this quadratic. And if I did my math right, I came up with 15,625. So now we have our vertex. And if you can interpret this vertex, you can see you are not getting all the income you could. Decreasing your price by $5, how many times? That's what this interpretation means right here, this 5. This isn't just $5. What this means is is that we are going to decrease our price 5 times by $5. So we need to do some math here to come up with the new price that we're going to sell our items for, because we're leaving money on the table and we want to maximize our sales here. So to find this new price, we're going to decrease our price by $5, but we're going to do it 5 times for a total of, we're going to lower that price by 25 bucks. So now our new price becomes, for the items, $125. So that's our new price. And then we can expect a much better income. Our new maximum income then would be $15,625. Okay, just a quick review of the types of regression lines that are on your calculator. If you type your scatter plot in and it looks like it's in the shape of a parabola, this is a quadratic regression line, and your calc calls that a quad reg. If it's at all kind of sticking together and going up fairly in a straight line, either up or coming down linear, and your calc calls that a linreg. If you end up something with the shape of an S, now I kind of exaggerated this S so you can see it. A lot of times it's a little more subtle than that. This is a third degree equation, and it's called a cubic regression line. Sometimes you get a scatter plot that's all over the place and you can't tell, there's no relationship in the data. That's just neither, nothing, no regression line at all. All right, 2 examples left. First, a rocket is launched from the ground straight up with an initial velocity of 288 feet per second. What is the maximum height the rocket will reach? So I wrote the equation we use for, with gravity pulling the object down, initial velocity pushing it up. And when we see the maximum height, we know this is a vertex problem, but this is a whole lot more than just a vertex problem. So let's put in the 288 for the initial velocity. If the rocket is launched from the ground, h sub I, or the initial height, is 0, so I don't really need to put a plus 0 here, but I'll just show that to you. So again, I think I've done this step enough for you. Find the vertex by doing minus b over 2a. The vertex turns out to be 9, 1296. So let's interpret that vertex. What is the maximum height that the rocket will reach? Well, that's the top of the parabola, 1296 feet. How long will it take to reach that height? 9 seconds. 9 seconds, the time is the independent. So now that we have found the maximum height and how long it takes to reach that height, just did a little picture here, that's the vertex. So it took 9 seconds to reach that. Now the next question is, how long will it take to reach the ground? So I want to find the time right here where it reaches the ground. So you can do the 0 of the function, or you can realize that it reached the vertex at the halfway point, so it's going to take another 9 seconds to finish the path here, and it's going to hit the ground in 18 seconds. Now here comes the interesting question. How high will the rocket be after 10 seconds goes by? So that's right about here is 10 seconds right there, and it's not going to be at the peak height anymore. It's going to have come down a little bit. So like right there, it came down a little bit, and we need to find that, and there's a couple different ways to do this. Right here on the graph at 10 seconds, that's where x is equal to 10, and we want to find the height. So we could find this function, this h, right at the 10-second point. So you could plug 10 in for x, or in this case, plug 10 in for t, which is the time. So when I plug in the 10 and do the math, I get that the rocket will be 1,280 feet off the ground. And that makes sense because it came past the vertex and started coming down a little bit in that 1 second. So now the next question we're asked, at what times will the rocket be 500 feet high? Okay, now the 500 is way down here somewhere, right about there. And if you draw a line across this parabola, there's going to be twice where this rocket is exactly 500 feet above the ground, on the way up and again on the way down. And so you have to figure out how are you going to find both of those times, the times will be in seconds, that the rocket is 500 feet high. So if I drew some lines down from those points, I want to find this second, these seconds right here, and these seconds right here. I do not know the x. But this 500 is here on the y-axis. So I could plug that in for the y in the equation. And I could say that 500 is equal to negative 16t squared plus 288t. And now this is a new quadratic with 500 as the y value, and we know how to solve this for t. So I subtracted the 500 over here, and now we have a new quadratic, and we want to find where this crosses the x. We basically, in essence, what we did is we took this parabola and we dropped it down 500 feet, and so that this line is now on the x-axis, and we want to find these zeros. So I chose to type this into the calculator and do the zeros, and if I did this correctly, I ended up with 1.95 seconds. After 1.95 seconds, the rocket is 500 feet off the ground, and then on the way back down, 16.05 seconds, it is also at 500 feet. Okay, finally the last example. We're asked to write the general form equation of the parabola passing through these points. Now remember, general is standard form. We're given the vertex and a point that it passes through. So I know I have to start with the vertex form. So we'll do the vertex form, and then at the end we will multiply it out and get the standard form. So this is kind of like those y equals mx plus b problems where out of the 4 letters you knew 3 of them. Well, here we have 5 letters, and out of these 5 letters we know 4 of them. So we're going to plug in the 4 that we know and solve for the 5th one. It helps me to put the letters above the numbers so that I realize where to put them. The vertex we know is HK, and any point that the graph passes through is one of the xy's on that graph. So let's substitute these numbers in. So now I need to find A by doing the math. 3 squared is 9, so I have 9A minus 7. Add a 7 to both sides, divide by 9, and we get A is 3. So now that I know A and I know the vertex, I can write this parabola in its vertex form. I put in the 3 where the A goes, and it says minus h, and h is already a negative 2, so that would become a plus 2 squared, and then the k is just minus 7. So now I'm almost there. I have the vertex form, but I'm asked for the general form. So let's FOIL this out and multiply by 3. So when I FOIL that out, I get x squared plus 4x plus 4. Doing the distribution with the 3, and then finally combining those like terms. I get a standard form quadratic equation of 3x squared plus 12x plus 5. All right, now we have the knowledge we need, I hope, to do section 6.4. So have fun with those word problems.